Factor and graph p of x equals x cubed plus 3x squared minus x minus 3. In part A, factor algebraically using the integral zero theorem. Rewrite the polynomial. The first step is to use the integral zero theorem to determine potential zeros of the polynomial. The potential zeros of the polynomial are the factors of the constant term. The integral factors of -3 are plus minus 1 and plus minus 3. The second step is to determine which potential zeros are actual zeros of the polynomial. The calculations for this step are shown. The zeros of the polynomial are -3, -1, and 1. If the number of unique zeros is equal to the degree of the polynomial, and the leading coefficient of the polynomial is 1, we can factor immediately. Otherwise, use synthetic division to factor the polynomial. The degree of the polynomial is 3, we have 3 unique zeros, and the leading coefficient is 1. We can write the factored form immediately. A zero of -3 corresponds to a factor of x plus 3. A zero of -1 corresponds to a factor of x plus 1. A zero of 1 corresponds to a factor of x minus 1. The factored form of the polynomial is p of x equals x plus 3 times x plus 1 times x minus 1. In part B, use technology to graph the polynomial. Can the polynomial be factored using just the graph? Use a graphing calculator to obtain the graph of the polynomial. The graph lets us quickly locate the x-intercepts of -3, -1, and 1. We can determine the multiplicity of each zero by inspecting the shape of the graph at the x-intercepts. The leading coefficient of the polynomial is 1, so the factored form is p of x equals x plus 3 times x plus 1 times x minus 1. This is the same result we found in part A. In part C, can p of x be factored any other way? Rewrite the polynomial. In previous math courses, you learned how to factor by grouping. Not all polynomials can be factored using this technique, but this particular polynomial can. Factor x squared from the first two terms and -1 from the last two terms. Factor out the common expression x plus 3. Factor the difference of squares. The factored polynomial is x plus 3 times x minus 1 times x plus 1. This is the same result that we found in parts A and B.